another part of beta decay now. This part I really like to think about. Let's say that we know that beta decay has an electron. That can be measured. We can check that out. So if we go from and we know that a neutron goes to a proton, at least that was experimentally figured out. So because it has a extra charge to it, then we get a neutron. But I mean nitrogen. And then let's talk about this other part that says what would this spectrum look like if it was just an electron? So we're going from a neutron, which is producing two items or a two body problem, which would say we've got the proton recoil from the electron shooting out. So, what would this spectrum look like? What would the energies look like that came from that? Well, it would be a nice, neat spike on an energy spectrum thing, which is the way that alpha particles, a nice, neat spark, because we go from a atom to a alpha particle, which is like a helium nucleus. But I'm starting to get off track here. So let's talk about that spike. The thing is, when you look at the spectrum, it's not a nice, neat spike. It's a continuous, or it goes like this really, a continuous spectrum where it dips up and then it finally just comes down. So, what could cause that? Well, let's think. What does happen, which we know or we've theorized and we've actually been able to detect, but originally what happens is we've got a three body problem. We've got a neutron and it emits three different things. It produces a proton, so there's some recoil from the other stuff that happens. We produce a proton, an electron, and an electron neutrino. So that's three things. And sometimes you've heard a three body problem is very complicated to try and predict, because what happens is we've got three different things interacting. And because it's three different things, if it was just a neutrino that was put out, then and we were able to detect the energy, then we know that energy would be a nice, neat spike for the electron neutrino or antineutrino, actually, in this case. So, how do we figure that? Well, with three bodies, it's very hard to figure out what's going to happen, or it's very randomized. And because of that, that's why we get that continuous spectrum. So, that theory or that thought process is what came up with the idea that there must be a neutrino in there.